Hey guys, long time no see. Well, I believe you guys have been hearing me for a while now. So, in the previous video, we were talking about substitution. We know that substitution reaction goes for exclusively alkanes, where we need UV light, which is obviously a part of the sunlight. And what happens is that an alkane molecule will lose one of its hydrogen atoms, and a halogen atom takes that position, and the hydrogen atom is lost. But it does not go away alone. It makes a bond with the other halogen atom. So we need a halogen molecule, we need UV light, and we need obviously alkane. We know what happens, we know how to write the equation as well. That UV light provides a catalyst, it works as a catalyst. One of the halogen atom takes the position of the hydrogen, the other accompanies the losing hydrogen. Now we're going to be trying some past paper questions. So I have this question over here in my booklet. We'll see that this question belongs to 2011 May-June. It is question A2 from that exam. Now we are trying it. So let's pick a good color to write the answers. The first question is, alkanes are a homologous series of saturated hydrocarbons. Okay, we already know this. What is the general formula of alkanes? So I know the general formula is CnH2n plus 2. So carbon N, hydrogen double N plus 2, because hydrogens are 2 extra within alkanes. The next question says, draw these structures. So it wants me to draw these structures of two isomers of C4H10. C4H10 is butane, and the isomer of that would be isobutane. Okay, so I can draw a butane by drawing just 4 carbons in a line, 1 2 3 4, and the isomer would be 3 carbons in a line and 1 branch, but the branch always comes from the center, so a branch comes like this. I'll put my hydrogens over here. So I'm drawing the hydrogens, just enough hydrogens for each carbon to have total of 4 bonds. If your carbon is in the center with 2 bonds already, you give 2 more. If your carbon is in the corner with 1 bond only, you give it 3 more. Like it gets 3 more. The carbon in the center gets only 1 more because it made already 3. This carbon gets 3, this carbon gets 3 more bonds. Okay, let's highlight this like it's a straight chain. This one is the 3 carbon chain with 1 branch. This one is butane, and this one is isobutane. One of the isomers of C4H10, butane, reacts with chlorine. Okay, it reacts with chlorine in the presence of UV light. If you guys remember, we did talk about such a reaction just in the last video. It forms hydrogen chloride. I know this, that it forms HCl and a mixture of liquid compounds. So you get a mixture of liquid compounds. Name this type of reaction. We know this type of reaction is known as substitution. Substitution. Draw the structure of one of the liquid compounds. Now we know, okay, let's suppose whatever the structure is in the beginning, let's suppose this was the structure in the beginning. What happens in the substitution reaction? One of the hydrogen goes away. So let's draw the whole structure with all its 4 carbons. 1 2 3 4. Let's draw the hydrogen atoms, but we'll remove one of the hydrogens. It's totally your call, but you have to remove one of the hydrogens because you know some other atom is gonna come over here. I have already drawn 1 less hydrogen. Now when it reacts with chlorine, obviously a chlorine atom should come over here. Now here we have a new chlorine atom. What happened to the hydrogen which was lost? It doesn't go away alone, it makes a bond with a Cl atom. So this is substitution. Name the process by which the butane is separated from crude oil. So this is something that we'll talk shortly, but they are separated on the basis of their boiling point. So the process is fractional distillation. In fractional distillation, we separate various liquid compounds on the basis of their different boiling points. So this is fractional distillation. I have one more question on page number 119, and I was really looking forward to solving it with you guys. So let's come on page number 119. These are solutions from the other questions that we'll be talking about soon. Yeah, so 119. The question is, alkenes are a homologous series of organic compounds. Well, I know this. Alkenes are a homologous series. Okay. The table shows some information about the first 6 alkenes. I can see their names, their molecular formula, their melting point, their boiling point. Okay. Draw the structure showing all the atoms and bonds of propene. So I have to draw the structure of propene with all the atoms. I'm looking for this. This is enough place for me to draw it. So I know I have to draw all the bonds and all the atoms in propene. Propene means 3 carbons, right? So propene means 3 carbons, and obviously ene means alkene. So I'm going to be drawing 3 carbons, 1, 2 and 3. But I have to make sure that there is a double bond, because alkene has a double bond. So at least at one point I draw a carbon-carbon double bond I have got over here. Now I draw enough hydrogens for each carbon so that every carbon has 4 bonds. So 3 over here, only 1 bond over here, because this carbon has already drawn 3 bonds with carbons, so it gets only 1 with the hydrogen. This carbon gets 2 more, and this is propene. It is a 3 carbon compound with 1 carbon-carbon double bond. Let's do the next question. It says, use the structure to explain why propene is both a hydrocarbon and unsaturated. So we know the definition of hydrocarbon. So we say that propene is a hydrocarbon as it has only carbon and hydrogen atoms. No, it was really important to say the only part, because there are so many compounds with carbon, hydrogen and other atoms. But you mentioned that it is only carbon and hydrogen atoms and no other atom. So that's why it's a hydrocarbon. Why is propene unsaturated? Because propene is unsaturated as it has carbon-carbon double bond. Carbon-carbon double bond. You can add the details by saying it has 2 less hydrogens than a 3 carbon alkane. 3 carbon alkane. But that is extra detail, so your answer would be enough if you even said like this over here. That would be enough for us. Now coming back, there are several compounds with molecular formula C4H8. Okay, each one has different structure. They have different structure essentially. What name is given to the compounds with the same molecular formula but different structure? Okay, so we know that these compounds with same formula but different structures are called isomers. Deduce the molecular formula of decene. We need the molecular formula of decene, which is an alkene with 10 carbon atoms. So if it's an alkene, the general formula should be CnH_n. If carbon is equals to 10, hydrogen should be equal to 10 times 2, which is 20. So the formula becomes C10H20. Explain why it is easier to predict the boiling point of heptene rather than its melting point. Now we'll have to go to the data for it. We can see, okay, that the boiling point keeps on increasing. It was negative initially, then it kept on increasing, and on it increased. But the boiling point decreased in the beginning. It became from -169 to -185, which is a decrease. It decreased in the beginning, then it stayed the same, then it increased, so it's not a proper pattern over here. I cannot see a proper trend. So the idea is going to be that boiling point follows a smooth trend and a pattern, but melting point does not seem to be following a proper smooth trend. Just saying smooth trend is enough. You don't have to explain that it increased or increased or stayed the same or whatever. Just saying the fact that it is following a smooth trend or it is not following a smooth trend is enough. Now question part E says, what is the physical state for butene at room temperature and pressure? So I'll have to go to the data of butene. I can see butene is right over here. Butene has a melting point which is less than room temperature, 20 degrees centigrade, and it has a boiling point even lesser, again less than 20 degrees Celsius or even 25 degrees Celsius. So melting and boiling point are both less than room temperature. So anything with such scenario is going to be a gas at room temperature and pressure. Why? Because its boiling point and its melting point are both less than room temperature. So that should be it for us. So we tried solving few P2 questions to have an idea of how to solve these questions. In the next video we're going to be talking about the addition reaction, guys, so stay tuned.